Okay, continuing from the previous lecture, we were talking about numerical solutions to equations or iteration, and we had done questions where we learned how to do iteration. Let's start doing this. It says sketch the curve ln x plus 1. Now, if you've completed logarithms, you must have learned how to sketch the curve ln x, and I'm going to use that to sketch ln x plus 1, and hence by sketching a second curve, show that the equation this equals to that. Now, in order to make this a question on two curves, what I'm going to do is I'm going to say that the x cube goes to the other side. Now, one curve that I'm talking about is ln x plus 1, and the other curve that I'm talking about is 40 minus x cube. Now, in order to make sense, what I've done is, you see, I've solved simultaneously and I've ended up with this equation, which is why I am drawing these two curves to prove that the intersection point of these two curves will be the same as the root of the equation. Has exactly one root. State the equation of the second curve. So I've already stated the equation of the second curve for you. I will now sketch it. It has to be a small sketch. It doesn't have to be exactly uh, accurate. So I'm going to say that normally ln x goes like this, but if you remember transformation from AS, you should understand that this curve has moved backwards by 1 unit. So I'm going to say that it no longer touches minus 1 and it goes something like this. I'm going to erase the original one. Okay, so this is a parallel transformation and I'm going to erase this one. Okay, I messed up a little. This has to pass through 0. Okay, so that is what you have as the graph of ln x plus 1. Now, drawing the graph of 40 minus x cube, I hope that you remember from O levels that x cube looks like this. We also drew it in a previous part. Now, when I say minus x cube, it's basically a deflection in the y-axis. So the graph of minus x cube will look like this, and 40. So 40 plus, which means that the graph has moved 40 units up, and it's going something like this. You see, I cannot draw an accurate graph here because 40 is too large for me to handle right now. So that is what the graph of 40 minus x cube will look like. That is the graph of ln x plus 1, and that should be enough for you to get these 3 marks. Okay. Then verify by calculation that the root lies between 3 and 4. Now, if you remember from the previous lecture, I cannot verify till I bring everything on one side and say that this becomes a function of x. Then I can plug in values of x and y, x, and show that the y values go from negative to positive. So I'm going to first plug in 3 cube. That makes it ln 4 minus 40. So 27 plus ln 4 minus 40 gives me minus 11.61. That's f of 3. F of 4 is 3 power 4 plus ln 5 minus 40, and that's 42.61. So from negative to positive, y value indicates root between 3 and 4. Then says use the iterative formula. It's constructed an iterative formula for you. So what you simply need to do is go ahead and do the iteration. As emphasized before, you will take the midpoint as x1, and like yesterday, I am going to open up the calculator for you and show you the iterative process. Okay, so I have my calculator in front of me right now. What I'm going to do is I'm going to first write x1 equals to 3.5, and that is what I'm going to do on my calculator as well. Write 3.5 and press equals to. For x2, I'm going to construct this expression on my calculator. I'm going to write shift and cube root of 40 minus ln answer plus 1. And then when I press equals to, I get my first iteration 3.37. It says give the result of each iteration correct to 5 decimal places, 654, and the root correct to 3 decimal places. So I'm going to write 3.377. I press another equals to get my next iteration, and that gives me 3.37735, and that also rounds off to 3.377. I press another third time, 3.3773435, and that's my root repeating itself. So the root is 3.377. Then it says deduce the root of the equation this. Now in order to deduce the root of this equation, when it says deduce, it has to do something from the previous part, and that is what I'm going to do. I am going to compare the previous equation to this one. Now when I write down these two equations side by side, I'll be able to see something. Let's see what I'm able to see. Plus y equals to 40, and x cube plus ln x plus 1 equals to 40. Okay, so what I see is 40 matches with 40, which means that the right hand side matches, which means that the left hand side must also match. I see a cube and I see cube. So can I say that e power minus 1, e power y minus 1 should equal x? I compare the cubes, and that leads me to y equals to ln x plus 1 as well. They should also balance. That is my gut feeling. Let's see if those two give me the same answer. Can I derive one from the other? Okay, so I write down e power y equals to x plus 1, and when I remove e, I have to take an ln to the other side, ln x plus 1. So I got exactly what I wanted. So that proves that both these terms when compared together give me the same answer. Now I already have the answer for x, and that is ln 3.377 plus 1. So y is therefore 1.48. That's what the question says, correct to 2 decimal places. Okay, that is the end of this question. Let's move to the other question. It is more or less the same, but there's this part that's different, which is why I'm doing this question. So this is the equation. This has one positive real root denoted by alpha. Show that alpha lies between 1 and 2. So in order to again prove to you, what I need to do is create a function. So I'm going to bring everything to one side. You can either cross multiply or just bring it like that. It's up to you entirely on what you want to do. That is what I'm going to do. I'm going to say that f of x is equals to x minus 10 over e power 2x minus 1. I could also cross multiply and do that. I can just simply say now that f of 1 and f of 2 are two values that I need to calculate. So I'm going to do that. 1 minus 10 over e power 2 minus 1, and that gives me 0 minus 0.5652. Now I'm going to plug in 2. Oh, I should be doing this on the screen calculator. Okay, let's do that. So f of 2, so 2 minus 10 over, my bad, 10 over e power, that would become 4, and minus 1, that gives me 1.813. So that's from negative to positive, indicates root. Okay, That's part one. Then part two is a little different. It says show that if a sequence of positive values given by the iterative formula this converge, then it converges to alpha. Now, what is the meaning of converge? Let's look at that first. Now, what I want you to understand is that converge means meet or get together at a particular point. So what I am saying is that each of these iterations, what I was actually trying to do is to see what values they converge at. So this x was converging to 3.377 eventually. When I did these iterations, it started from far away 1.3863 and 1.39, but ultimately the values converged to 1.26. That is what convergence means. Now, if you look at this equation, this question is telling you that if this sequence is converging to a particular root, I don't know what that number might be. Let's say that number is 5.75. Let's say this is it's not 5.75, it has to be between 1 and 2, so 1.575, let's say. So if this is converging to 1.575, then this will also converge to 1.575, which means that they technically have to be the same equation. Now if they are the same equation, how do I prove that to you? Now, if you remember from the first few questions, what I said was when I've isolated x, this n plus 1 is a subscript that I essentially put in myself in order to construct an iterative formula. This x with the subscript of n is also another thing that I do in order to construct an iterative formula. In essence, when I was constructing this iterative formula, I would have gotten this as the starting point, and then I would have introduced the subscripts. And how would I have gotten this? I would have changed the form of this earlier question and brought it to this form so that I could construct an iterative formula. See, the iterative formula involves making one of the x variables the subject of the equation in order to start the iterative process. That's when you start off with x1 and then x2 and x3 and so on. So can I now prove to you that this equation is the same as the other one? Let's try doing that. So I get 2x equals to ln 1 plus 10 over x. Ln moves to the other side and makes e power 2x. And then I have e power 2x minus 1 equals to 10 over x. Can I now exchange these and show to you that this is the same equation that I had in part 1, uh, in the original question essentially? So that means that my answer is correct, and I've proven to you that they are essentially the same equation. If I find the root from the iteration, that would be the root of the original question as well. Then it says use the iterative formula. So I'm going to use an iterative formula and say that part 3 starts off with x1 equals to 1.5. Again, I'm doing this on my calculator. I'm going to first write 1.5 and say equals to, and then construct this entire formula for myself on my calculator. Ln 1 plus 10 over answer. Okay. 1.0184. I'll give the result of each iteration to 4 decimal places. So 1.0184, and the result of alpha correct to 2 decimal places, 1.02. That's x2, that's x3, 1.1906, 1.19. X4 gives me 1.1203, 1.12. X5 gives me 1.1476, 1.15. X6 gives me 1.1368, 1.14. X7 gives me 1.14102, 1.1410 should work. That rounds off to 1.14, and then x8 also gives me this. So I know that my sequence has converged, and it's converged to a value of 1.14. So my value for alpha, or the root of that original equation, is 1.14. Moving on. Okay, then with your P3 exam, what I want you to understand with the next question is that this question can combine a lot of other topics as well. For the first part, you can have differentiation, you could have integration, you could have trigonometry, and anything else actually. We've also seen it in differential equations. One of the questions is about that. So this graph says the graph shows this and that. When x equals to a, the tangents to the curve are parallel, which means that their gradients are the same, so that alpha satisfies the equation. Now I know that when I want to calculate the gradient of a curve, I need to do dy by dx. So I'm doing that for the first curve, so e power 2x minus 3 into 2, and for the other curve, dy by dx equals to 2 over 1 over x, 2 into 1 over x. So they're both the same at the value x equals to a. So I'm going to say that I'm going to plug into a, 2 minus 3 equals to 2 into 1 over a. And I want to show you that this simplifies to I. So I need to make one of the a's the subject, and I need an ln. What I am noticing is that this 2 can cancel out with the other 2. So I'm left with 1 over a. I remove this e, so it becomes an ln on the other side, so this becomes ln 1 over a. So I have 2a minus 3 equals to ln 1 minus ln a, and I get 2a equals to minus ln a plus 3. Yeah, that is what I wanted, 3 minus ln a. Ln 1 is 0 basically, so that's the reason I have this, 3 minus ln a. Okay, so I have this, and then I have proved to you in part 1. So verify by calculation that this equation has a root between 1 and 2. So in order to prove to you that the root is between 1 and 2, I need to create a function. So I'm going to move everything to one side and create a function. You could do it by cross multiplying, you could do it by anything else as well. This is f of a. I'm going to first plug in 1 and ask the calculator if that is what I want. Uh, so 1 minus 0.5 into 3 minus ln 1 is 0, so just 3. So I get minus half, and then f of 2 is 2 minus half, 3 minus ln 2. Punching that on my calculator, I get 0.847. Y goes from negative to positive. Therefore, root lies between 1 and 2. Okay, then part 3. Use the iterative formula. This now they've constructed an iterative formula, and I want you to notice that the subscript is a and then a plus 1 and then an here. So I am also going to do that. I'm going to say that that is my iterative formula. What is my starting value? My starting value is 1.5 because it's again the root, so a1 is 1.5. Let's again construct this on our calculator. I'm going to say that I'm going to use the iterative formula now, this iterative formula, and I'm going to write half into 3 minus ln answer. Okay, I didn't plug in the initial value, which means that I need to first do that. 1.5 equals to half into 3 minus ln 1 point, oh sorry, ln of answer. So I get A2 as 1.2973, 1.30. I press another equals to. I get 1.3699. I'm following the requirements of the question, 4 decimal places and 2 decimal places, so I get 1.37. And another equals to 1.3426. That gives me 1.34, 1.35, and 1.3527. Another equals to gives me 1.35, 1.348. That's 1.3490. Okay, that's A6. And I know it's going to repeat. I'm run out of space here, but I just write that. So even with 2 repetitions, you can stop and say that that is the root. 1.35 is the root. Okay, I hope this video was helpful. This also combines with trigonometry and some inverse and some more trigonometric graphs. Please like and subscribe for future videos. Thank you for watching.